Here we are on page 4 of exponential models. We're graphing still. So we're going to do a couple more graphing exercises. And as usual, we will turn on the calculator and turn on y equals. And carefully type these in with the parentheses. Right? To the negative x power. So the negative here, you would want to use this one and not the minus sign, because whenever you have a minus sign at the beginning in the TI-84, you must use this one and not the minus sign. It's a negative sign instead of a minus sign. And then minus 1. Graph. Okay, so we can see that basically it occupies a little bit on the negative y, and then a lot on the positive y. So let's look at the grid, or the table. Okay, so we got we'll put the x-axis here. Oops. X-axis here, y-axis here. In -2, it's about -1. -1, -0.8. 0, 1. 1, 19. Oh my God, that's already way off the screen. Okay, kind of like that. Whereas the asymptote, the asymptote's right there at y equals -1. Okay, let's go on to number 8. Oh, if you want to write a few numbers into your grid here, you could put -1, -0.8, 0, 1, and 119. Let's do the next one. The next one is 0.4 to the negative x plus 2. So looking at this, we can already predict that the horizontal asymptote is going to be at y equals 2. When we have a number less than 1 to the negative power, it's like two opposites that cancel each other out. So basically we get a growth function anyway. Because normally when you have a fractional, when you have a base that's less than 1, you think, okay, it's going to decay, it's going to go down. If you have a negative x in the exponent, you expect it to go down. But if you have both, they kind of cancel each other out. Okay, that's why you end up getting growth in this case. So let's look at the table. And looks like the asymptote is at 2, right? Just like we predicted. So let's write some of these numbers down in our table. So we have -1, 2.4. We got 0, 3. We got 1, 4.5. We got 2, 8.25. And let's take a look at the graph for a second. Just give us an idea where to put our x-axis and y-axis. Yes, it looks like the x-axis could just be here at the bottom. Oops. The y-axis could be maybe here in the middle. And let's mark some of the points. So -1, 2.4, 0, 3, 1, 4.5, and 2, 8.5. 8.25 actually. Okay, and our asymptote is at +2. By the way, let's write down our horizontal asymptote. Our horizontal asymptote is -1. Our horizontal asymptote here is y equals 2. Anything else we need to write down? we do need to write down the y-intercept. The y-intercept for 7 is 0, 1. And the y-intercept for 8 is 0, 3. So the y-intercept for 7 is 1. The y-intercept for 8 is 3. Okay, and we can confirm that in our drawing too. Look, there, 1 and 3. Okay, let's look at number 9. So we're going to put 3 parentheses, 0.2, close parentheses, to the negative x plus 4. So we can see that our horizontal asymptote is going to be 4. Let's check out our data table. So for 9, we're going to put like negative 1, 4.6. Put 0, 7, 1, 19. Okay, and our horizontal asymptote is y equals 4. Okay, so if we draw our x-axis here and our y-axis here, let's graph some of our points. So negative 1, 4.6, 0, 7, and 1, 9? Or is it 19? I think it's 19, right? I think I wrote it down wrong. Yes, 19. Oops. It's 19. So this one's like totally off the screen. So let's graph this, and we know that the asymptote is at y equals 4. There's our asymptote right there. All right, and so the y-intercept in this particular case is 0, 7. The y-intercept equals 7. Let's try one more time. 5 parentheses, 3 parentheses, to the negative x minus 2. Graph. Interesting. Now we're going to take a look at the grid, the table. So we got negative 1, 13, 0, 3, 1, negative 0.333. Okay. So we got couple things underneath the x-axis, so we'll put it here. Got the y-axis here. Mark some points. Negative 113 is like way down, or way up, up here. 0, 3 is about here. 1, negative 0.333 is about there. Oops. And remember that our horizontal asymptote is going to be at y equals negative 2, which is right there. Okay, so if you go up, oops, wrong way. If you go to the positive x values, you can see that you approach negative 2 as the asymptote, like we predicted. Okay, all right, now let's go down to the last question, which is in a different section. This is going to ask us to sketch 2 graphs. So this part is pretty much the same, except we're going to graph them on the same domain, on the same grid. And then we're going to write down the coordinates of the point of intersection, which we're going to do with our calculator. And you've done that before with lines, but in this case, we're going to be doing it with exponential curves. And you've probably done it with quadratics too. Okay, so let's do that. We're going to graph two different functions. So the first one's going to be 2 to the x. Let's just clear this. 2 to the x plus 0.5. That's the first function. Second function is 2 to the negative x plus 0.5 also. And you notice they give us a domain of -3 to 3. So we could kind of like optimize our graph here by putting that domain into the window. So I'm going to put, for the domain of the window, I'm going to put -3 to 3. -3 to 3. Then I'm going to graph it. We're getting a nice little picture here. Looks like a wine glass kind of, with the stand and like a little bowl without a stem. So there's our graphs, and let's look at the table so that we can get some points for our tables here. Interesting. Okay, so let's start with x equals -3. So -3, -2, -1, 0. And so for the first function, which is 2 to the x plus 0.5, we got very small numbers at -3, -2, and -1. We get 0.75 for -2. We get -1, 1. We have 0, 1.5. We have 1, 2.5. And we have 2, 4.5. Let's look at the other one. So the other one has -3, 8.5. By the way, for the first function, 3 is 8.5 too. So I'm going to put 3 and 8.5 up here at the top. Okay. -3, 8.5. -2, 4.5. -1, 2.5. 0, 1.5. 1, 1. And 2, 0.75. So let's try to graph this now. There are no negative y values, so I'm just going to put the x-axis here, and I'm going to put the y-axis here right in the middle. And then first I'm going to graph this function in blue, and then I'm going to graph this function in orange. Okay, so first we'll do the blue function. 3, 8.5, 3, 8.5. -2, 7.5, -2, 7.5, 0.75, -1, 1, 0, 1.5, 2, 1, 2.5, and 2, 4.5. Okay, so that's the blue function. Now I'm going to graph the orange function. -3, 8.5. -2, 4.5. -1, 3.2. -1, 2.5. 0, 1.5. And 1, 1. And 2.75. Okay. For part A, it says to find the point of intersection between the two curves. And you can kind of tell that the point of intersection is 0, 1.5 because that coordinate pair appears in both lists. But it's also possible to see it using the second calc intersect function, which is a little bit more of a sure thing. So I could go second calc intersect, which is number 5. First curve, is it 2 to the x plus 0.5? Yes, it is. Second curve, is it 2 to the negative x plus 0.5? Yes, it is. What's your guess? And the guess only matters if you have two intersections or more and you want to specify which intersection you're looking for. In this case, we only have one intersection, so it doesn't really matter. You can just hit any number for guess. And then the intersection is 0, 1.5, like we said. Okay. Next step. The next step is to find the horizontal asymptote of both graphs. So again, the best thing to do is to look at the table. And then, for example, if we look at this table, we can see that like if we go this way, y1 just gets really big. So we want it to approach a number. In order to do that, we're going to have to go in the negative direction. And we can see that it gets closer and closer to 0.5 apparently, right? So the horizontal asymptote for the first function, which is this one, is going to be y equals 1.5. I'm sorry, y equals 0.5. And that makes sense because if you look at the function, remember how this added term here is equal to the horizontal asymptote in the case of exponential functions? So that makes sense, right? And then if we go the other way, like for example, we want to find the the horizontal asymptote of y2, we're going to go in the positive direction. And when we do, we can see that the number just gets smaller and smaller, and then it also approaches 0.5. So in both cases, the equation of the horizontal asymptote is y equals 0.5. If we were going to draw this asymptote, let's do this. We're going to draw it here, but it's going to be kind of hard because I'm using this fat marker. But basically it's at 0, y equals 0.5. Okay, so the blue and the orange curve are not approaching the red line, they're approaching this yellow highlighted line. Okay, and that's it for this page.